Now, as we have seen the definition of the central force field, that central force is always directed towards the center, and it is a function of only distance from the center of the central force field. Okay, and we have seen the examples also. Now let us see some properties of the central force field. The central force field is always represented as r cap f of r. Okay, which means that this central force is a only function of the distance from the center of the central force field. Okay, now the motion of the particle in the central force field is always irrotational or a planar. When a particle is moving in a central force field, its motion is always irrotational or the planar. What is the meaning of this? Let us see. Um, let us prove this by this small equation. We know that this tau is equal to dl upon dt. L is a angular momentum. I can write d by dt of r cross p, where p is a momentum. When there is a multiplication, I can write r dp by dt plus p dr by dt. Now we know that p is a momentum and p is equal to mv r cross d by dt of mv plus mv, and this dr by dt is nothing but velocity vector. Now we know that the cross product of a vector with itself is 0, then this term will become 0, and I can write this first term as r multiplied by m dv by dt, where dv by dt is acceleration, r cross m into a. So this ma is nothing but the force, and as we are studying the motion of the particle in a central force field, this force can be represented by this equation number 1, which is a function of the only distance, and I can write that f of r by using the same statement that the cross product of a vector with itself is 0. We can take this tau as equal to 0. Similarly, I can write this dl by dt is also equal to 0. Therefore, I can write this L is equal to constant. So what is the meaning of this is, again, the central force field is direction independent, which means that this direction of the central force field is not changing. Okay, that's why this dl by dt is equal to 0 and L is equal to constant, means the direction of the force always remains constant. It is not changing its plane. Therefore, it is called as a irrotational force or the planar force.